Ever wonder how we might teach a computer to, actually see, like to go beyond just recognizing pixels and really understand what's in an image?
It's a fascinating challenge, right? And that's really what computer vision is all about.
Exactly. It's this field that's, well, it's already changing so much,
Yeah,
from self-driving cars to medical diagnoses.
absolutely. And at the heart of a lot of these computer vision breakthroughs are these things called convolutional neural networks.
Right, convolutional neural networks. They're basically like the engine behind AI's visual understanding.
Yeah, you could think of it that way.
But I've heard that they kind of have tunnel vision, right? Like they
Huh.
focus on these little bits of an image, but don't always grasp the whole picture.
That's a pretty good analogy.
Yeah.
They're kind of like those detectives who are super detail-oriented,
Yeah.
meticulously going over every little clue.
Yeah.
But sometimes they might miss the bigger picture, the context of the whole crime scene. They're great at spotting patterns, like edges or textures, but struggle to understand how different parts of an image actually relate to each other.
So how do we give these detectives a wider view then? How do we teach them to connect the dots and see the whole story that an image is trying to tell?
Well, that's exactly what we're diving into today. We're going to be looking at this research paper from Google Brain,
Okay.
and they're, real pioneers when it comes to AI. And this paper is all about something called attention augmentation.
Attention augmentation. Sounds intriguing. So is it like giving the computer a magnifying glass or something so it can zoom in on the most important parts of the image?
Well, it's more sophisticated than a magnifying glass, but you're thinking in the right direction. Imagine like giving the computer the power to analyze an image and then create its own heat map, highlighting the areas that are like the most relevant for understanding what's going on.
Interesting.
That's basically what self-attention does.
Ah, okay. So instead of just processing every pixel equally, the network learns to prioritize certain parts of the image. Sort of like how, well, like how our eyes are drawn to certain details when we look at something.
Exactly. And if you look at, say, figure 2 in the paper, you can actually see these attention maps that the network creates.
Wow.
It's actually pretty fascinating to see which parts of the image light up. It shows what the computer is focusing on.
That's incredible. But images are two-dimensional, right? It's not like text, which is linear.
Right.
So how did they apply this whole attention concept, which seems better suited for like processing words in a sentence, to something like a photograph?
Well, that's where it gets really clever. They came up with this method called two-dimensional relative attention.
Okay.
It's specifically designed to work with the spatial relationships within an image.
Hmm.
It makes sure the computer not only understands what it's seeing, but also where each element is in relation to everything else.
So it's not just about recognizing, say, a cat in a picture, but understanding that the cat is on top of a table next to a window and
Yeah,
so on.
precisely.
Those relationships are, I mean, they're key for actually making sense of the whole scene.
Exactly. And the really ingenious part of this two-dimensional relative attention is that it allows the network to capture these things called long-range dependencies,
Okay.
which are basically like connections between parts of the image that are far apart, something that traditional convolutional networks often miss.
So it's like giving the computer a mental map of the image where everything has its own unique coordinates.
Yeah, that's a great way to put it.
So then it can navigate that visual space and understand how everything fits together.
Right.
That's pretty cool. So we have these two approaches then.
Hmm.
Convolutions, which are like our detail-oriented detectives, and then self-attention, which gives us this broader perspective, the understanding of relationships. So did the researchers, pit these approaches against each other to see which one was better?
That's interesting. Actually, what they found was that combining the two was the real breakthrough. Instead of replacing convolutions completely, they augmented them with this self-attention mechanism.
Hmm. So it's not about getting rid of the old tools, it's about making them even better by like adding this new layer of understanding.
Exactly.
So how did they actually integrate these two approaches?
Well, they essentially combined the information coming from both the convolutional layers and the self-attention layers. So you have the convolutional layers giving you all these detailed features, and then the self-attention layers capturing the broader context and relationships.
It's like having two different lenses, right? Like
Yeah.
one for close-ups and one for those wide shots.
Yeah.
And you're able to combine the insights from both. That's pretty neat. So what was the impact? Did it actually make a difference in how well the computer could see?
Well, the results were actually pretty remarkable. They tested this whole attention augmentation thing on image classification tasks, and they used this data set called ImageNet, which is, it's kind of like the gold standard for testing computer vision algorithms.
So the million-dollar question, Did adding attention actually improve the computer's ability to, classify images correctly?
It totally did. In fact, the attention-augmented networks consistently outperformed their non-augmented counterparts,
Wow.
showed significant gains in accuracy across the board.
That's impressive. But even more interesting than just the accuracy boost is understanding why it works so well, right?
Right.
Is it simply that the network is just seeing more? Or is there something deeper happening?
That's a great question. And it really gets to the heart of why this research is so exciting. Because the results suggest that attention isn't just helping the network process more information, it's helping it understand the information more deeply.
So it's not just about quantity, it's about quality of information. The network is learning to prioritize, to focus on the things that really matter for understanding what it's seeing.
Exactly.
Yeah.
And that has some pretty fascinating implications for the future of AI. But first, I think it's worth delving a little deeper into one particular finding that really surprised the researchers.
Oh.
It has to do with the performance of fully attentional networks.
Fully attentional networks. What does that even mean?
It basically means getting rid of those convolutional layers entirely
Oh, wow.
and just relying on attention to process the images.
Huh.
That's a pretty bold idea, right?
Yeah.
And it really challenges a lot of the assumptions we've had about how, computer vision should work.
So instead of those detail-oriented convolutional layers, the network is learning to understand the image just through these relationships and connections. It's building its understanding from how the different parts of the image relate to each other.
Exactly. And what's really remarkable is that these fully attentional networks, they actually perform surprisingly well.
Really?
On certain tasks, at least. I mean, they didn't quite match the accuracy of those attention-augmented networks, the ones that combine both approaches.
Yeah.
But the fact that they were even close is, well, it's incredibly intriguing.
That's mind-boggling. It's like maybe attention is actually more fundamental to, visual understanding than we thought.
Yeah.
It makes you wonder, could we actually create AI that can see and understand the world just through attention without needing those convolutional building blocks that we've always relied on?
It's definitely a possibility.
Yeah.
And it opens up all these new avenues of research, right? Like, what can these fully attentional networks really do?
Mm-hmm.
And how can we optimize them? It's pretty exciting stuff.
Yeah, I can already picture a future where AI is powered by these super elegant attention mechanisms, effortlessly understanding these complex scenes
Right.
and making decisions based on like a really deep and intuitive grasp of, the visual world.
That's a pretty compelling vision, yeah.
Yeah.
But as with any really powerful technology, there are some
Yeah.
practical challenges. I mean, one of the biggest hurdles with self-attention, especially when you're dealing with large, high-resolution images, it's the computational cost.
Ah, yeah, because the network is basically comparing every part of the image to every other part, trying to figure out how it all relates. That's going to be a ton of processing power, right?
It is. And as the images get, larger and more complex, the computational demands just like explode.
Right.
That's why the researchers in this paper actually explored some pretty clever strategies to kind of mitigate that cost
Yeah.
without sacrificing performance.
So, like, what kind of tricks are we talking about here?
Well, one approach is to downsample the images before feeding them to the self-attention layers.
Okay.
So you're basically reducing the resolution of the image, which means fewer comparisons for the network to make.
So it's like creating a smaller, more manageable version of the image,
Right.
but you're still keeping the essential information.
Exactly. And they found that even with this downsampling, the attention mechanisms could still capture those important long-range dependencies
Yeah.
and, understand the relationships within the image.
That's good. But downsampling still feels like like a workaround, right? Like a way to make the existing methods more efficient.
Mm-hmm.
Are there any like fundamentally new approaches to attention that could deal with this computational bottleneck?
There are definitely some exciting avenues being explored. One of the things they mentioned in the paper is developing more efficient attention mechanisms,
Hmm.
ones that don't need to compare every single part of the image to every other part.
So instead of this like exhaustive, all-encompassing attention, the network could learn to be more selective, right?
So
Focusing only on the most relevant comparisons.
it's kind of like, when you're reading a book, you don't try to absorb every single word, right?
Right.
You focus on the key sentences and paragraphs.
That makes a lot of sense. And that could potentially, that could lead to some pretty dramatic reductions in the computational cost.
Exactly. Another really intriguing possibility is The development of specialized hardware,
Okay.
specifically designed to run these attention operations efficiently.
So instead of relying on, general purpose processors that are good at a lot of things, but not necessarily optimized for attention, we could have chips that are like purpose built for this specific type of computation.
Precisely. We've already seen that happen in other areas of AI, right?
Yeah.
Where custom designed hardware has just led to these huge performance gains.
Right.
So it's definitely conceivable that the same thing could happen with attention mechanisms.
Imagine that. AI systems running on these, sleek, efficient attention chips, just processing information incredibly fast.
Yeah,
That could revolutionize everything, from self-driving cars to medical imaging.
absolutely. And while we're talking about potential applications, I think it's worth highlighting some of the real world problems that these attention augmented networks could help us solve.
Yeah, we've touched on a few examples like self-driving cars and medical diagnosis, but it feels like there's so much more.
Oh, absolutely. One area that I think is particularly ripe for disruption is robotics.
Yeah.
Robots rely heavily on computer vision
Right.
to navigate their environment, interact
Mm.
with objects, perform tasks.
Right.
Attention augmentation could make them so much better at understanding complex scenes, making them more versatile and capable.
It's not just about recognizing objects anymore. It's about understanding the context, right? The spatial relationships, all those subtle cues that humans pick up on without even thinking.
Exactly.
Attention could give robots that level of sophistication.
And as robots become, more intelligent and adaptable, they can take on a wider range of tasks,
Mhm.
from assisting with surgery to exploring hazardous environments.
It's pretty amazing to think about. But with any really powerful technology, it's important to consider the potential downsides as well.
You're absolutely right. As these attention-augmented networks become more sophisticated and more integrated into our lives,
Hmm.
we really need to think carefully about the implications.
Yeah, it's not enough to just focus on the technical advancements.
Right.
We also need to have like a real thoughtful discussion about the ethical, societal, and economic impacts.
Absolutely. And that's a conversation we'll continue in the next part of our deep dive.
It really feels like we're at this like turning point where AI is, well, it's not just mimicking human intelligence anymore. It's almost like it's developing its own way of seeing and understanding.
It's pretty credible to think about, right?
Yeah.
And as we learn more about these attention mechanisms, we might even find that the line between, artificial and natural intelligence is, well, maybe it's not as clear as we once thought.
Maybe by studying how these artificial systems learn, we can actually gain new insights into, our own brains and how we think.
Yeah, that's a really fascinating idea. But I think for now, let's shift gears a bit and talk about some of the ways these attention-augmented networks could actually, impact our lives in the near future.
Oh, okay.
We've mentioned a few areas already, but I think it's worth, diving a little deeper.
Absolutely. One area I'm really interested in is healthcare. It's easy to imagine AI playing a bigger role, but how could these attention-based systems specifically make a difference?
Well, imagine if AI could analyze medical images, with this incredible level of detail and nuance, even better than, even the most skilled human radiologist.
Wow.
They could spot these tiny abnormalities that, a human might miss.
Right.
And that could lead to like earlier diagnoses and more effective treatments.
Yeah, early detection is, it's so important for so many diseases. It's not just about, proving accuracy. It's about giving people a real fighting chance.
Exactly. And it goes beyond just diagnosis too, right?
Yeah.
These systems could help us understand like the underlying mechanisms of disease, which could lead to, new drug discoveries and therapies.
It's like having this army of tireless medical researchers, working around the clock, analyzing data, searching for those patterns that could, unlock the secrets of human health.
Yeah, that's a great way to put it. And,
Yeah.
beyond healthcare, think about the potential in, say, manufacturing and quality control.
Okay.
Imagine AI that can inspect products on assembly lines with, like, superhuman precision, catching defects that, well, that would normally slip through.
Right.
That could lead to safer products, more efficient manufacturing, even less waste.
It's pretty incredible. But, with all these potential benefits, we have to remember that there are, potential downsides and challenges that we need to be thinking about too.
Absolutely. One of the biggest concerns is, potential job displacement.
Yeah.
As these AI systems get more and more capable, they may be able to automate tasks that are currently done by, by humans.
Right.
And that could, lead to some pretty significant job losses.
It's a valid concern. I mean, we've seen this happen throughout history, haven't we? New technologies come along, they disrupt existing industries, and then they create new ones. The key is, I guess, to anticipate these changes and figure out how to, you know, adapt.
Yeah, I agree. We really need to invest in, like, education and training programs. Give people the skills they need to thrive in this, this new world where AI is playing such a big role.
Yeah, it's not about replacing humans with machines, is it? It's about finding ways for, well, for humans and machines to work together,
Exactly.
combining our strengths.
Right.
And, beyond just job displacement, there are some really important ethical things to consider too. Like, how do we ensure fairness, transparency, accountability in these systems?
You're absolutely right. It's not enough to just focus on the technical capabilities. We need to make sure these technologies are being used, responsibly and ethically.
This deep dive has been, well, it's been an amazing journey. We started by exploring, how these attention augmented networks work, uncovered all this potential they have to, change all kinds of fields, and then even grappled with the ethical side of things. And I feel like we're just, scratching the surface here.
It's a really exciting time to be working in this field. And as we keep exploring these mysteries of, attention and intelligence, both artificial and natural, I think we're going to unlock even more incredible possibilities.
It's a future full of potential, right?
Yeah.
And it's really up to us to make sure we shape it wisely. And to our listeners, we hope this deep dive has, sparked your curiosity and maybe even inspired you to join the conversation about the future AI. It's something that affects all of us.